Hello guys, in this video we are going to see how we can implement linear regression using OLS, that is ordinary least square. Okay. Now in our previous video we have already seen how to implement linear regression using gradient descent. But now let's go ahead and try to see with the help of OLS. Now the major aim is that guys, over here you knew that in the gradient descent, right? Whenever I have some kind of data points, my best thing, my main aim using linear regression using gradient descent is that I need to find out this best fit line. And finding out this best fit line was done using an optimized algorithm, right? Some optimization was actually done, right? And this optimization usually happened with the help of loss function we have basically used. And for that, if you remember, we used something called as a gradient descent, right? And at every point, we try to calculate the derivative. And based on that, we try to come near to the global minima. So this particular point was something like global minima. Now, what does OLS technique basically say? OLS technique basically say that suppose if I have a specific data points, can I apply some formula and calculate my beta 0, that is my intercept, and my coefficient, that is beta 1. So that is what ordinary least square basically tells us. Okay. Now we will try to see with the help of some formula how we can basically calculate beta 0 and beta 1. But before I go ahead and directly tell you the formula, first of all, we'll try to understand, or we'll try to derive this formula also by understanding the aim of OLS. Again, as usual, the aim of ordinary least square is that we should try to reduce this error, right? We should try to reduce this error that is between the predicted and the truth point, right? So this is basically the error with respect to any best fit line that we create, right? So here, what you can do is that, again, let's say that if I have another line, if I have some line like this, so for this, the intercept will be different, the coefficient will be different. For this, the intercept will be different, the coefficient will be different. But we should try to select that line which gives us a less error. So now let's go ahead and let's try to derive the formula for OLS. And again, guys, OLS, here I'm just going to give a notation. Let's say this is my ordinary least square. Okay. You know what is the aim of ordinary least square? I'm going to give you a notation with S. Let's say this is beta 0 and beta 1. Let's consider that this best fit line is given by h theta of x is equal to beta 0 plus beta 1 into x1. I'm just considering this as a simple linear regression. And as said, in the ordinary least square, I'm not going to use any loss function like mean squared error, but I'm just trying to say that, okay, I have a scenario wherein I need to reduce my difference between y of I and h theta of x. What is h theta of x? H theta of x is nothing but beta 0 plus beta 1 multiplied by x1. And this is nothing but my predicted value y hat. So I'm just going to use this particular equation like this and probably write over here. This minus will get subtracted to this. Okay. So it will become minus beta 0 plus, and it will be minus beta 1 into x1. And this should be whole square. So here what I'm doing is that I'm just trying to reduce the error. Okay. My aim is that this difference that I'm actually getting, this is basically the error. Okay. And I'm just going to reduce this specific error. And obviously this basically looks like a mean squared error formula itself, right? So OLS by default, I think it uses mean squared error. Okay. And if I try to find out the average, it will be divided by n. Okay. So 1 by n multiplied by this. So here let me write it by white pen only, otherwise you'll get confused. So this will be 1 by n y of I minus beta 0 plus beta 1 into x1. Now in ordinary least square, the aim is we need to calculate beta 0 and beta 1. And obviously we'll try to derive the formula through which beta 0 and beta 1 can be calculated. So before I go ahead and talk about this, in gradient descent also we try to find out derivative, right, with respect to every coefficient, and we try to come to the global minima. Okay. Now what we are trying to do is that we are trying to find out what should be the formula of beta 0 and beta 1. In order to find it, first of all, what I'll do is that I will try to calculate the derivative. So derivative of ds of d beta 0, and let's say beta 0 comma beta 1 is over here. Here I can specifically write this as, okay. Now if I try to find out the derivative of this value, what it will happen? See guys, if I have an x square value, and if I have y is equal to x square, and if I write derivative of y with respect to derivative of x, then this what will happen? It will say 2x 2 minus 1 multiplied by x, right? Sorry, multiplied by derivative of x, right? This is what exactly happens, right? And then finally I get 2x because derivative of x with respect to x is 1, right? So if I have an equation y is equal to x square, and if I try to find out the derivative of y with respect to x, I'm going to get 2x. Now similarly over here, you'll be able to see that if I try to find out the derivative, what will happen? This will be 2 by n, okay, summation of 1 to n, and then I will write this entire equation, y of I minus beta 0 minus beta 1 x1. Now here it will be 2 minus 1, right? 2 minus 1. So I'm not going to write 1 separately over here. And in the next one, I'm just going to find out the derivative of this entire value, right? With respect to beta 0. This becomes a constant. So obviously this will be 0 minus beta 0 is there. Then this will become minus 1. Sorry, 1, because derivative of beta 0 with respect to beta 0 is 1. And then here you can see that this will again be a constant. So I'm going to write minus 0. So at all, if I try to find out derivative of s with respect to derivative of beta 0 with respect to beta 0 comma beta 1, I'm going to get 2 by n minus 2 by n summation of I is equal to 1 to n y of I minus beta 0 minus beta 1 x1, right? This is what I'm actually going to get. So this I'll be assigning it to 0. So this will become my first equation, let's say, okay? This will become my first equation because I need to derive beta 0 and beta 1. Similarly, if I write derivative of s with respect to derivative of beta 1 with beta 0 comma beta 1, here the equation that I'm actually going to use again, what I'm going to do, I'm going to find out the derivative with respect to beta 1, right? Then again it will be what? 2 by n, okay? And this will be summation of I is equal to 1 to n. And here I will write y of I minus beta 0 minus beta 1 x1. Now this entire thing I have to find out the derivative. Now this will become a constant, this will become a constant, and finally I will be getting minus beta 1, sorry, minus x1, right? Why x1? Because derivative of this value with respect to beta 1, this beta 1 will become 1 and x1 will get remained, right? So now I will assign this to 0. So this will basically become my second equation, okay? And this equation again, I can basically write it over here because I'm just trying to prove you what is the formula, okay? I is equal to 1 to n beta 0 beta 1 x1 multiplied by x1, which is equal to 0. Okay, so this is my entire equation and this becomes my second equation. Now with the help of this two equation, what I'm actually going to do, I'm going to basically simplify this equation and try to find out what is beta 0 and beta 1, and we'll try to calculate. Now let's go ahead and take the equation 1. Okay, now equation 1 is what? 2 by n, right? Or minus 2 by n summation of I is equal to 1 to n y of I minus beta 0 minus beta 1 x1, right? So here I'm going to take minus 2 by n summation of I is equal to 1 to n. This is y of I minus beta 0 minus beta 1 into x of I is equal to 0. Okay. Now let's consider this 2. I'm just taking this equation. This is my equation 1 and we'll try to calculate what beta 0 or beta 1 will be. Okay. Now in this equation, when I take this 2 below and if I put it to the denominator, this will be 0 by 2. Then obviously I'm going to get 0. And if I take it up, it is obviously going to be 0. So here in this equation, I can also write something like this. I will now write summation of I is equal to 1 to n, and this will be minus over here. Y of I minus beta 0 minus beta 1 x of I, which will be equal to 0. Now let's go ahead and multiply this summation of I is equal to 1 to n along with y of I, right? So now here you'll be able to see I will be getting minus summation of I is equal to 1 to n y of I. This will be plus, since I don't have any variable that is ranging between 1 to n. So here I can directly multiply n multiplied by beta 0 minus, and again this minus into minus will be plus, and here you know that I can write beta 1 summation of I is equal to 1 to n x of I is equal to 0. Okay. So this is what we have actually done over here. Now all I have to do is that I can basically consider n multiplied by beta 0 plus beta 1 multiplied by summation of I is equal to 1 to n x of I is equal to, I'll move this entire equation over here. So this will become summation of I is equal to 1 to n y of I. Okay. Now again, my aim is basically to calculate beta 0. Let's say from this, I'll be writing beta 0 is equal to, now here you have summation of I is equal to 1 to n y of I minus, if I take this value over here, then it will be beta 1 summation of I is equal to 1 to n x of I. Okay. And here you already know that I have n. Now n, what I'm actually going to do over here, I'm going to move it in the below denominator. So let's say this is also divided by n and this is also divided by n. Okay. So finally, I can prove that my beta 0 is nothing but, if what is happening over here, see, this is nothing but, this is the summation of y of I divided by n. So this, can I say this is the average? So definitely I can write this as y of y hat, right? So this becomes an average. And similarly over here, x of I, summation of I is equal to 1 to n x of I divided by n. This is nothing but beta 1 multiplied by x bar. So beta 0 in this entire equation can be calculated by using this particular equation, right? So my intercept, if I really want to calculate my intercept can be calculated by using this formula. Okay. So just imagine we have taken the first equation from here after doing the derivative and we have computed how to calculate beta 0. Now let's take the second equation and let's do the same thing, right? Now in the second equation, you know that it is minus 2 by n. So here what I'm going to do, let's consider equation 2. Let's consider equation 2. Now since we have got beta 0 over here, obviously now it will become easy to get the beta 1, right? And beta 0 is nothing but it is the intercept. Now equation 2, I'm just going to write minus 2 by n. So let's go ahead and write over here minus 2 by n, and here I'm just going to write it down from my notes. I is equal to 1 to n y of I minus beta 0 minus beta 1 x of I multiplied by x of I, right, is equal to 0, right? So this is the equation that I actually have. Now this 2 will go to the denominator, n will go to the numerator, so everything will become 0. So now I can write this equation as, again same thing, here I'm just going to write summation of I is equal to 1 to n y of I minus beta 0 beta 1 x of I multiplied by x of I, which is equal to 0. Okay. And the next thing that we are probably going to do over here is that let's multiply x of I and summation of I is equal to 1 to n inside this. Okay. So after we multiply this, here you'll be able to see I'll be getting summation of I is equal to 1 to n x of I multiplied by y of I. So this will be xi yi, and then I will get minus beta 0 summation of I is equal to 1 to n, and this x of I will get multiplied over here, and minus here you'll be seeing I'll be getting beta 1 summation of I is equal to 1 to n, and this will be x of I whole square, right? So this is the equation that will happen after doing all these things. Now one common thing that you see is summation of I is equal to 1 to n. So what I can do, I can take it as summation of I is equal to 1 to n, then this will become x of I, y of I, and this will be beta 0 of x of I, and this will be beta 1 into x of I whole square, right? And this will be, let me write like this, beta 1 x of I whole square, and this will be basically equal to 0, right? Now you know that beta 0 value you already know. It is y hat minus beta 1 into x bar. So what I'm going to do, I'm going to replace beta 0 with y hat minus beta 1 into x. So if I replace this into this beta 1 into x bar, right, then what will now happen? Now let me go ahead and write in different color. So this will be summation of I is equal to 1 to n x of I, y of I minus beta 0 is nothing but y hat minus beta 1 into x bar, and then you have x of I minus beta 1 x1 x of I whole square, and this is basically equal to 0. So guys, now once we replace beta 0 by y bar minus beta 1 into x bar, here you'll be able to see this. Now in the next step, what I will do, I will just write summation of I is equal to 1 to n, and I will be multiplying x of I inside this, okay? So this will be x of I, y of I minus x of I, y bar. Then this minus into minus will be plus. Then here I can write beta 1 x bar x of I minus beta 1 x of I whole square. Now you will be knowing why we are doing all these things, because at the end of the day, we'll be getting an equation to find out beta 1, okay? Now, the next step after this, what we basically do is that here, in all this equation, the most common thing that you'll be finding is x of I. So let me remove x of I outside. So here we'll basically have y of I minus y bar plus beta 1 into x bar minus beta 1 into x of I, and this x of I will come outside, okay? Now what we do, you can remove this x of I by just putting this in the denominator. So obviously this will be entirely 0 only this side, and this x of I can also be lost. Now the next thing that we are going to do, I will write summation of I is equal to 1 to n, and here I will write y of I minus y bar, okay? So this is my first equation, and then I will also say beta 1, and what I'll do here, I will write x bar minus x of I is equal to 0, okay? Finally. Now, the next step that we are going to do, and obviously I can also take this as a separate group, y of I minus y bar together, right? We can also take this like this together, right? Because understand, I'm just grouping this and I'm taking a common of beta 1, and I'm basically writing beta 1 x bar minus x. Now, what I'm going to do here, I'll write beta 1. Let's say that this is there outside in my complete bracket. Now, if I try to multiply this summation of I1, then it will be summation of I is equal to 1, y of I minus y bar, okay, plus summation of I is equal to 1 to n, beta 1 x bar minus x of I, okay. So this is what I'm actually going to get with respect to 0, okay. So I've just made it into two groups, okay. Now, after this, I can definitely write something like this, summation of I is equal to 1 to n, beta 1 x bar minus x of I, and here I'm just going to take this as minus, and this will be summation of I is equal to 1 to n, y of I minus y bar. I'm just taking this particular equation at this side. Then finally, I will be getting beta 1, which will nothing be, it will be minus summation of I is equal to 1 to n, okay, y of I minus y bar, okay, y of I minus y bar divided by summation of I is equal to 1 to n, and this will be x bar minus x of I. Now see over here, if I try to bring this x of I forward, then I have to probably take a negative value. So here, finally you'll be seeing that beta 1, I can write it as minus I is equal to 1 to n, y of I minus y bar. And if I take a minus value outside, then I can also write this as I is equal to 1 to n and x of I minus x bar, right? This minus and minus will get cancelled. And finally, my equation of beta 1 will be summation of I is equal to 1 to n, y of I minus y hat divided by summation of I is equal to 1 to n, x of I minus x bar, right? So this is my entire equation of calculating beta 1. And if you remember, beta 1 is nothing but it is the intercept. So sorry, it is the coefficient. So finally, I have actually proved you that with the help of OLS, if you really want to calculate the beta 0, then your formula is basically given over here, which I have actually proved it, y hat minus beta 1 into x bar. So here you'll be seeing y hat minus beta 1, I think beta 1, right? Let me write a beta 1 into x bar, right? X bar. This equation is basically to calculate the intercept. This equation is basically to calculate the intercept. And in order to calculate the coefficient, we use this specific equation, that is y of I minus y bar divided by x of I minus x bar. So let's say I have some data points x comma y, and here you'll be having some values, okay. From this, obviously you'll be able to calculate x bar and y bar, and all you have to do in order to calculate beta 0, you just have to equate this particular equation, y bar minus beta 1 into x. First of all, if you really want to calculate beta 1, first of all, we'll go ahead and calculate beta 1 over here. And beta 1, you know y of I, y hat. So you'll go and compute this component, you'll go ahead and compute this component, and you will divide this both, you'll get beta 1. Once you get beta 1, you can equate this is over here, right? So first thing, let's see over here, you will calculate y of I minus y bar, right? With respect to every point, you know, whatever y bar is that, you'll get all these values, right? And then you'll calculate xi minus x bar. Here you'll be getting all the values. Then you divide in both of them. Once you divide in both of them, you will basically be getting beta 1. And after that, you can equate in this particular equation, beta 0 equal to y hat minus beta 1 into x bar. Then you'll be able to get your intercept. So this is basically your coefficient. And this is basically your intercept. Now this is with respect to a simple linear regression. In multiple linear regression, again, this equation will change. But at the end of the day, here you'll be having more other components, okay? But just to give you an idea, like how ordinary least square is basically calculating, here I have derived you some kind of formulas, okay? So I hope you have understood this. And in the upcoming videos, we'll try to do both practical implementation using linear regression using sklearn and the OLS method, and we'll try to compare the results. If you compare the results, the OLS method will approximately be giving the same value when compared to a normal linear regression using sklearn. Okay, this is for sure. So I will show you an example as we go ahead by doing some practical implementation. So yes, I will see you all in the next video. Thank you.